In this video, we're going to discuss a heat exchanger of a 90% efficiency furnace. What you see in front of you is the front of a heat exchanger where you see the intake ports of the heat exchanger. At the very top, where you see the 5 openings. At the bottom of the front is the secondary heat exchangers, where you see the ports for the inlet and exiting of the flue gases and condensate. As we get closer, we take a look. These, like I say, are the openings where the burners will be set at. It will be the end shot type burners. This is the limit control, and below is the ports for the secondary heat exchanger as the flue gas is exiting and the condensate is coming out to go to a trap. Also inside of these, we have these little radiant panels inside of the secondary heat exchanger tubes. These panels are designed to slow down the flue gases to allow it to be heat extracted from it while the gas slows down. These little radiant panels are made out of stainless steel, so it doesn't rust, because the condensate is very corrosive and if it was mild steel or aluminum, would actually damage it and wear it out within a very short time. To take a look at it, you can see where the high limit control is located, and we take a look on the inside of it. We see the how it's extended and have a thermal disc which is sensing the heat from the heat exchanger. There's a plate there to help keep from the heat rising, to deflect some of the heat, so it's actually sensing temperature from the heat exchanger itself. As I back out, we can see the passages of the heat exchanger. Starting at the top where the burner will be located on the outside, it's very large as the heat comes in, and as it goes through, these channels actually decrease in sizes as the velocity increases. Then they put these dimples in to actually slow down the flow so it can extract the heat out before it goes into the secondary heat exchanger. The secondary heat exchanger is almost like a condenser coil. It's made out of stainless steel, but it has very small passages. These passages are used to separate the volume of flue gases which carry the heat to be able to extract the heat from it easier. Now, this secondary heat exchanger is located right below, right above actually, the blower wheel. So it's actually getting the coolest temperature air which is touching this to help have a very high TD to extract heat from the secondary heat exchanger before you even get to the primary heat exchanger. So as we look at how it is constructed, we can see that the ports is exactly the same. Each clamshell heat exchanger is exactly the same for each one, and each burner has its own section to be able to extract heat. But the secondary heat exchanger is designed to take the great bulk of heat energy and cause a latent heat change inside of these tubes. They put fins on it to help give it more surface area, so these fins actually will aid in pulling the heat out of these tubes. So by taking the flue gases, separating them into very small passages, putting fins on it, it will be able to have a latent heat change going from a gas to a liquid. So basically in the very front, as the flue gases come out, it would collect inside of a collector box, and the water would go to the bottom and go to a drain. So basically this is how a high efficiency condensing unit, condensating furnace will operate to make the furnace as efficient as possible. These days, they are getting up to 97% efficiency out of these type furnaces. So there's something we need to look at, because normally we do not see what the heat exchanger look like. We do not see where the secondary heat exchanger is located, but with this cutaway being removed, we can actually understand the process of heat extraction from a heat exchanger.